Alright, so I'm just making this video for those of you that are still confused about circles and just want a little bit further instruction. Now a circle is the first type of conic that we go over in this unit. So in this unit we're going over circles and then ellipse and then hyperbola. And then we're going to do some word problems. We cut out parabolas because we have done them so often in the past. We did them for an entire couple of units in Algebra 2. We did them at the beginning of this pre-cal year. So we're not really going over parabolas. Today is dedicated, however, to circles, just circles, which you did go over in geometry. I know it was so many years ago, but we did have a whole unit on circles. Now, we have two equations for a circle. We have the general equation, which is kind of like, if we're looking at a quadratic, it's kind of like the ax squared plus bx plus c formula. However, just like we learned with ellipses, we really want to concentrate on this standard equation for a circle, because this standard equation immediately tells us the center, h and k. H is added or subtracted from x, and k is added or subtracted from y. And remember that these values are backwards. So if I have an h value of 2, so my center has an x value of 2, in the equation, this would read x minus 2. It's always backwards. You always negate the h and k value to get your true center. Then also, the r is the radius, and a circle is always set equal to r squared. So if in our circle the radius had been 3, the standard equation for a circle would be set equal to 9, because we would have to square 3 for our standard equation. And that's about it for the general concepts of a circle. Let's go ahead and graph it. So here, the two things that we have to identify for a circle are the center and the radius. In our equation, our center is determined by h and k. The h comes after the x and the k comes after the y. So here, this -2 will determine my h and the -1 will determine my k. But remember, they're negated. So my center has an x value of, instead of -2, a positive 2. And it has a y value, a k value, not -1, but a positive 1. So my center is at 2, 1. Then what the standard equation for a circle is set equal to determines our radius squared. This 49 is what our radius squared is equal to. So our radius in this case is actually the square root of 49, or 7. Remember, to get our radius, you'll always have to square root that number. So then to finish graphing this, I'm just going to count 7 in every direction. So and you only have to do 4, left and right, up and down. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 6, 7. And then to finish graphing a circle, you connect your points, which is very tricky. Okay, that's pretty good. And we're done. We're done with graphing a circle. Circles are the easiest to graph out of the conics. Now in the second example, notice that we don't have a number added or subtracted from x. This means that our h value is 0. And our k value is a -4. It's the opposite from what is added or subtracted from y. And our radius is the square root of 25, or 5. So I'm going to graph 0, -4, and I'm going to go 5 in every direction. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. That looks like 6 to me. What's going on? Yeah, that's right. And then I connect, and I'm done graphing. Whoops. Okay, pretty good. So yes, both of these were given to us in standard equation. That's why it was so easy to just jump right in and graph them. However, sometimes they'll give us the general equation for a circle. Let me erase this. So if I'm looking right here at part 3, both 1 and 2 are circles, and they're circles in the general equation format. Meaning, if I wanted to know the circle's attributes, I would need to convert from general to standard. The only way to do this is by completing the square, which we did do in Algebra 2 with quadratics. Now, to complete the square, what you're basically doing is you're taking a quadratic, which we're going to turn the circles into 2 quadratics. You take a quadratic and you add something into the quadratic so that it can be factored into a perfect square. So if I'm looking at this little example here, x squared plus bx plus blank, the problem would give us these 2 values, x squared plus bx. And we need to add this blank in so that this can be factored into a perfect square. Now the way that we do this is we add in the value b divided by 2 squared. So over here, my little example, my b value is 8. So what I'm going to be adding in here is 8 divided by 2, which is 4 squared, 16. So now, if I were to go ahead and actually factor this, I have 16 here and I have 8. What multiplies to be 16 but adds to be 8? 4 and 4. So this actually factors into x plus 4, which can be written as a perfect square. Notice, if I hadn't factored this, right, if I hadn't, and I had just known that this factors into x plus 4, notice that you can complete the square, this is called, you can complete the square without ever actually having to factor, because this number right here is always going to be half of your b value. Always. So you don't have to factor, you just have to remember, okay, I'm writing down here half of my b. So let's try it. Let's try it with a circle. Right here. Now this is just a little bit more tricky because we're going to have 2 separate quadratics we're going to have to deal with. One for x and one for y. Your first step is to group them. So I'm going to go ahead and group my x's. I'm also going to leave a space for the value I have to add in, like I was telling you before. And I'm going to group my y's. And again, leave a space. In this first step, you also have to move the constant it gives you to the other side of the equation. So that's all in one step. We group the x's, group the y's, and move the constant to the other side. So now I'm trying to complete the square for 2 separate quadratics, x first and then y. In the x quadratic, remember, I need to add in the value of b divided by 2 squared. So in this case, my b value is negative 14. Negative 14, so let me write this. Negative 14 divided by 2 is negative 7 squared is 49. So I'm adding in 49 here. However, you cannot just willy-nilly add values into an equation and have it be the exact same equation. You're creating an unbalanced equation. You're changing the location of this equation on the graph. That's not allowed, right? You're working with a totally different problem. But If you add in the same value on both sides of the equation, you're not actually changing its location. You're not changing the equation. So if I add in a 49 on the left, you must also add in a 49 on the right. This keeps it balanced. This keeps it the same equation. Now we're going to do the same thing for y. I'm going to add in an extra value here, and I find it by taking my b value, which is negative 18, dividing it by 2. Negative 18 divided by 2 is negative 9, and squaring it, and you get 81. And then we're going to add up all of these values on our right. So negative 105 plus 49 plus 81 is actually 25. So my right-hand side simplifies down to 25. And what we're now going to do is complete the square for both of these individual quadratics. Remember, you don't actually have to factor here. All you have to do is take your b value and divide it by 2. And I have completed the square for the x quadratic. And then you do the same thing for the y. You write the variable in a set of parentheses that are squared, and you divide the b value by 2. So again, all you do is take that b and divide it by 2. You take the b and you divide it by 2. And we are done. This is the equation of your circle in standard form. I can immediately look at this and tell you that the center is located at 7, 9. I can also tell you that the radius is equal to 5. And we're done. We can graph this. We know everything about this circle now. So let me do one more. We're actually going to change this. This was a misprint. We're going to change that 0 to be a 1. First thing I'm going to do is group my x's. We have, 4x squared. Nope, there is no other x. So 4x squared. And then I'll group my y's. And I'm going to leave a space. And I'm going to subtract 36 over, and I get negative 35 here. Now, I cannot, notice right here, I'm not having to complete the square for the 4x squared because there's just one term. I can't do anything with that. Instead, I'm looking at my y's first, and I notice that there's an a value here. You cannot complete the square when there is an a value on your leading term. We need to pull this a term outside of our parentheses, and this is exactly the same thing as pulling a GCF out. Now, if I'm pulling a GCF out, I need to pull it out of everything in my quadratic. So I'm dividing 4. Negative 24 divided by 4 is a negative 6. And I'm going to bring everything else down. So now I can complete the square for y. I need to insert a new value, a brand new value here in my y quadratic by taking my b value, which is negative 6, divided by 2, and I get negative 3 squared is a positive 9. And I cannot, now this is the most missed part, you cannot just add a 9 here. Because what I actually added into this y quadratic is not just 9, but 9 times that 4. That 9 is being multiplied by 4. So what I'm going to do instead is I'm going to add in that 4 times 9, which is 36. Negative 35 plus 36 is 1. And then I'm just going to bring down my 4x squared, bring down my 4, and I'm going to complete the square here for the y. Remember, you just take your b value and you divide it by 2. So now notice this still looks funny, right? This still doesn't look like what we think of as a circle. There are numbers in front of the x's, in front of our variables. Notice they're both 4. So to get these numbers off of our x and y values, all we have to do is divide both sides by 4. These 4's cancel, these 4's cancel, leaving us with x squared plus y minus 3 squared equals a 4th. So our center is located at 0, 3, and our radius is the square root of 1/4, which is 1/2. Okay, so now let's look at these word problems for circles. This is on page, well, the pages aren't numbered, so this is on a couple pages later. But we're just going to be going over these 2 problems, C and D, and then we'll be done for today. Part C says an earthquake can be felt for 30 miles from its epicenter. If you live 20 miles south and 25 miles west of the center, can you feel the earthquake? How far do you need to move for that answer to change, and in what direction? So what I'm going to do is I'm going to draw a little diagram with the center of these 2 axes being the center of your earthquake. And it can be felt for 30 miles in every direction. So this length here is 30, this length is 30, this length is 30, and 30, and 30, and 30, right? Everything is within this 30-mile radius. If you live 20 miles south and 25 miles west of the center, can you feel it? So the question becomes, is your house, if I'm going 20 miles south and 25 miles west, is your house within this circle or out of this circle? And the only way to find this out is if your radius is less than 30 or more than 30. And we know that this is 20 and this is 25. So guess what you're going to have to do here? Pythagorean theorem to figure out, okay, what is that hypotenuse length? Is it more than 30 or less than 30? So we have 20 squared plus 25 squared is equal to c squared. So all we have to plug into our calculator is 20 squared, a square root of 20 squared, plus 25 squared. And we get 32.02, which means that our house is outside of our circle's radius. Whoa, no. So it is this second dot, meaning we are safe. We don't have to move anywhere to make us safe. We don't have to worry about this earthquake. All right, using the graph to the right, answer the following questions. What is the value of f of -1/2? Now remember, function notation. If we have a value inside of the function's parentheses, this represents an x value. If it tells us f of x is equal to a certain number, this is a y value. So what we're doing first is we're looking for the value of f of x when our x value is -1/2. So it's about here. So I need to follow this until I reach my line. And I need to figure out what is the y value at that point. Now if you look at this circle, notice that it has a radius, or I should say, it has a diameter from end to end of 5, right? 1, 2, 3, 4, 5. That means our radius is going to be 2.5. And notice at -1/2 is right where the center of our circle is. So if I'm trying to figure out what my f of x value is for that -1/2, all I have to do is know that the radius is 2.5. From my center, I go up exactly 2.5 to get to the edge of my circle. So the y value here, the f of x value, is 2.5. Or, in terms of a fraction, which in most cases they want the answers here in terms of fractions, 5/2. 5 divided by 2 is our radius. Then next, if they want to know what our x value is when our f of x value is negative 3 over 2, negative 3 over 2 is about negative 1.5. So I go down 1.5. So I'm here. And I need to either go left or right until I line up with my graph. Which again, notice that this is the very center of the curve of the second circle, the lower circle. So I need to figure out what is my x value for that point. It being the exact center of that curve means that if I know that the diameter is 3, half of the diameter will tell me where this point's x value is located. So half of 3 is 1.5. So I'm going 2 and another 1.5, which is 3.5. Whoops. In terms of fractions, that is 7/2. So at the negative 3/2 value, my x value is 7/2. I don't really like this problem because, you see how the curves of the circles don't really seem to be going through that 2 points, so you really shouldn't just assume those are the centers, but that's what it's doing. It's just a poorly drawn graph. So I apologize for that. It says, write the equation to represent the function of the domain negative 3 to 2. So my x values of negative 3 to 2 produce this top circle. So what it wants me to do, basically, is to write the equation here for this circle. Now, the center point of this circle is located at negative 1/2, 0, right? That's the coordinate point. So in my equation of this circle, negative 1/2, oh God, what am I doing? I was writing down the coordinates of the circle. Remember, to write an equation of a circle, you have your x value and your y value set equal to the radius squared. So my x is paired with my h, which is the x value of the center, and it's always the opposite. So instead of writing a negative 1/2, I'm going to write plus 1/2. And then my y is paired with my k value of the center point, which is 0. So actually, this is just y squared. Set equal to the radius squared, which our radius here is actually, remember, 2.5 or 5/2. So 5/2 squared is 25/4. And that's the equation for that, that line from negative 3 to 2. It also wants us to write the equation for the other circle from 2 to 4. So again, my center point is located at 3.5, or I should write 7/2, comma, negative 3/2. So that means my equation is x minus 7/2 squared plus y plus 3/2 squared, with our radius, which our radius was 1.5, or in terms of a fraction, that's 3/2. So 3/2 squared is 9/4. And last but not least, find the total area of the shaded region of the domain of negative 3 to 4. Note, if the shaded area is below the x-axis, then the area is considered to be negative and subtracted from the total. So we need to figure out what the areas of each of these semicircles is. So if I call this circle A and this circle B, what this wants us to do, because it says that if it's below the x-axis, it's determined to be a negative area. So it wants us to take the A circle and subtract the B circle. And you know that area of a circle is pi r squared. So the A circle's area, remember it's a half circle. So if it was a complete circle, would have had the area of pi times the radius, which is 5/2 squared. But it's half a circle, so we divide this by 2. Minus the area of the B circle, which is pi times the radius, which is 3/2 squared, but it's half a circle, so we divide it by 2. 5/2 squared, remember, was 25/4. So this actually becomes, little side note here. I'm going to write this over here. If we have 25/4 over another denominator, what you can actually do to simplify this is bring this 4 down to the other denominator by multiplying it. So this becomes 25 pi over 8 minus 3/2 squared is 9/4. Remember, we can bring that 4 down to the other denominator by multiplying those denominators, so it becomes 9 pi over 4. Oh, 8. Sorry, 8. Which now we have like denominators. So we can go ahead and subtract these. 25 minus 9 is 16 pi over 8. And 16 divided by 8 is 2 pi units squared. We don't have a unit, so you can just put u there, units squared. And we're done.